This module will be the first of 3 examining the causes of honeybee declines on pests and pathogens of honeybees. For Master Gardeners pursuing their advanced certification, please take the pretest if you have not done so already. The link is available on the course homepage. Please be sure to complete the quizzes for the previous modules as well to receive credit for the course. By the end of this module, you will be familiar with the major pathogens contributing to stressed colonies in Hawaii, be able to identify the major pests of individual bees and whole hives, and understand the importance of good beekeeping practices for reducing overall pests in colonies. Although drastic and often unexplained losses in honeybees have been reported since 1869, the most recent period of declines experienced since around 2006 has earned the term colony collapse disorder, or CCD. This is a phenomenon defined by the presence of honey and pollen on the comb, the presence of capped brood and the queen, but all worker bees have left. There is no pile of dead bees, they're just gone, and it isn't clear where they go. Similar symptoms were reported at various points in the past 150 years with different names, like disappearing disease, giving rise to the idea that CCD could be a cyclical phenomenon in honeybees that had just been accepted in the days prior to mass commercialization. Today, beekeepers report annual losses anywhere from 30 to 90%, which is clearly unsustainable for long-term business viability. Nationally and internationally, honeybee overwinter losses can be attributed to 6 major factors. The first of these are pathogens, which can be viruses, funguses, or bacteria. Second are parasites, most notably the Varroa mite, which was introduced to Oahu in 2007 and the Big Island in 2008, with devastating consequences to the beekeeping industry. These mites not only lower the overall immunity of individuals, but they also transmit a number of viruses. Pesticides also contribute to declines, whether those applied in-hive to control hive pests or those that are sprayed in the environment or agricultural areas. Agricultural practices, such as monocultures, can destroy pollinator habitat and lead to reduced forage and compromised nutrition. Finally, some practices of beekeeping can also cause declines, such as migratory beekeeping, which adds additional stress to the bees and makes them more susceptible to other stressors. It's important to note that not all of these are relevant players in all locations, and it is likely combinations of factors that contribute to declines. This first module on declines will focus on pathogens and parasites, with an emphasis on those currently present in Hawaii, since we do not have all of the same issues that they have on the mainland. The most important thing you can do to detect issues with your colonies is to monitor them for abnormalities every time you enter your apiary. Assess the outsides of the colonies. Do you observe anything out of the ordinary? This could include vigorous activity at the hive entrance, which could mean you have a strong colony or a weak one that is being robbed. Check for an accumulation of dead adults, immature stages, and unusual or excessive debris at the entrance. Check for feces on the outside of the hive, which could be indicative of nosema infection. While most adult bee diseases are difficult to diagnose, Check to see if the adults are looking or behaving differently than normal. Examine the brood. Select a frame with all stages of brood development and check for uniform egg laying, consistent color in the cappings, and abnormal cappings that may be sunken or punctured. If so, the contents of these cells should be carefully examined. Use your nose too. Any sour or decaying smells coming from inside the hive also indicate disease. Come up with a numbering system for your hives and take careful notes every time you check them so you can better track changes through time. We'll start by going through the biology and symptoms of some of the major diseases impacting honeybees. This is in no way a comprehensive list of all the pathogens affecting honeybees, but includes the heavy hitters. We don't have the same issues in Hawaii that they do on the mainland, and it's also possible we have different pathogens not present on the mainland that aren't virulent enough to outright kill a colony, but can weaken them. Unfortunately, in-depth diagnostic screening services aren't available in the state. So more so than other places, beekeepers need to rely on their own knowledge when it comes to diagnosing issues. In almost all cases, the best preventative a beekeeper can provide for their bees is adequate nutrition. If you notice your bees are low on nectar or pollen, supplement with sugar water or protein to get them through. At least 19 viruses are reported to infect honeybees, with many having different strains of varying virulence. While they are spread by a variety of mechanisms, they are often associated with infections and infestations of other pathogens and parasites, especially Varroa mites. These mites are only present on Oahu and the Big Island, so our state offers unique research opportunities to study how this parasite affects viral infections in honeybees. I'll talk about this a little later on. Deformed wing virus is one of the easiest to identify in the hive. When virus levels are high enough in individual bees, the adults emerge with crumpled wings, smaller body size, and are discolored. They don't live long when they are symptomatic. Bees infected with acute bee paralysis virus, Israeli acute paralysis virus, chronic bee paralysis virus, and Kashmir bee virus exhibit similar symptoms. These include darkening and hairless thoraces and abdomens with wings that shiver. These bees are not able to fly and may tremble for a few days before dying. In severe infections, the bottom board may be covered with these shivering, dying bees. Most viral infections, however, are not easy to recognize, and their presence may be overlooked because they co-occur with other types of infections. All viruses listed on this slide are positively confirmed in Hawaii. We do participate in a nationwide survey to monitor for various known diseases in honeybees, which is why we know this, and further know that some common diseases on the mainland don't occur in Hawaii, such as black queen cell virus. A lot of research is currently being done by labs around the world on honeybee viruses, including improved diagnostics. For now, the only effective means of accurate identification involves molecular testing of infected bees in a laboratory. The best way to prevent viruses is good beekeeping practices. Disinfect hive tools with bleach, especially after entering a weak hive. Provide good nutrition, replace failing queens and old comb regularly, and control parasitic mites and other pathogens as necessary. Before parasitic mites were detected in the United States, American foul brood was considered the most serious honeybee disease. It is caused by the bacterium Penibacillus larvae and is spread by the spore stage of the bacteria, which remains viable for decades on used beekeeping equipment. Worker, drone, and queen larvae are all susceptible to AFB for up to 3 days after hatching, though drones are slightly less susceptible. Once the larva consumes a spore with their normal brood food, the spore germinates in the gut and penetrates through the gut wall, ultimately killing the larva through a septicemic condition, basically an ulcer from hell. The disease is spread by robbing bees who move the spores in honey and by beekeepers who inadvertently move honey or pollen from diseased to healthy colonies. An infected colony can be diagnosed by an experienced beekeeper by the decaying smell and symptoms in the brood. Combs of diseased brood may have a spotty or shotgun brood pattern, especially in severe infestations. Cappings of diseased brood are dark brown, usually punctured, and sunken into the cell. While healthy larvae are a pearly white color, diseased larvae undergo a color change ranging from dull white to brown to black as the disease progresses. When the larvae are brown, ropiness can be demonstrated by macerating the larva with a twig and pulling it slowly from the cell, resulting in a thread about an inch long. If you do not have experience with AFB or are unclear if your colony is infected, a specialist should be contacted to conduct laboratory diagnostic testing. Alternatively, you can purchase a test kit from a beekeeping supplier. No bee strains are immune to AFB. 3 antibiotics are approved for use in honeybee hives to treat AFB in Hawaii, but can only be prescribed and administered by a licensed veterinarian. Regardless, the best course of action to prevent the spread of spores to neighboring colonies is to burn everything: frames, hive bodies, and bees. Any attempt to save the bees and move them to another colony will likely spread spores. I know it isn't pleasant, and this will be a hard decision for some, but it's like when Old Yeller got rabies. They just gotta be put down. European foul brood is another bacterial infection of the brood caused by Melissococcus plutoneus, with a number of other associated organisms contributing to symptoms. In the past couple years, this disease has become increasingly common and difficult to treat on the mainland. EFB is spread by nurse bees, feeding young larvae from infected cells. The organism multiplies in the larva's gut and competes with the larva for food, causing an abnormal demand for food. The nurse bees are onto it, though, and will reject larvae eating too much. So when you have an otherwise healthy colony with a sufficient number of nurse bees, the colony can police itself and overcome infection without beekeeper intervention. Larvae turn yellow, then brown, with the tracheal or respiratory system becoming visible. When larvae die, they take on a twisted appearance and may also experience ropiness. The sour smell varies between infected colonies, as it is the result of other associated microorganisms. The scales that form after the larva dies and dries out are rubbery in appearance. Positive diagnosis is made in a laboratory, though beekeepers can purchase a test kit from Man Lake that is just as accurate. As I mentioned, when infections are low, treatment is not necessary, and a strong nectar flow will help take care of the issue. An option for moderate infections would be to requeen, as the break in egg laying allows the workers time to remove diseased larvae. Antibiotics are available for treatment and prevention, but can only be prescribed and administered by a licensed veterinarian. Chalk brood is a relatively common infection of drone and worker larvae, though less frequently observed in queen larvae. Once the fungal spores invade the 3 to 4 day old larva, the larva is overgrown by the fungus, which fills the entire brood cell. The white mass dries into a hard mummy, usually white, though may also appear mottled or completely black. This makes the disease easy to identify, as the workers will remove the dead mummified larvae, and you'll see them at the hive entrance and on the bottom board. This is not a disease that will kill a colony, though it is likely you will observe background levels here in Hawaii. No treatments are currently available, but the bees will take care of this on their own. The best help a beekeeper can give again is to maintain hygienic stocks of bees, meaning including genetics that encourage the bees behaviorally to remove diseased brood more quickly. Nosimosis is one of the most serious and prevalent diseases of adult honeybees worldwide and is caused by a single-celled fungal parasite or microsporidian, either Nosema apis or Nosema ceranae. This represses the immune system of the honeybee and makes it susceptible to secondary infections. Adults experience reduced lifespan, with nurse bees failing to develop to adequately feed the brood. Because adults are otherwise asymptomatic, the only way to detect Nosema infections is to count spores either from whole adults or in their feces, though fecal spots caused by bee diarrhea on the outside of the hive can be indicative of Nosema infection. Once an adult consumes the spores, they replicate in the gut and are expelled in the feces. When this occurs inside the hive, like during cooler times of the year, workers cleaning out the mess then become infected themselves. The best thing you can do to keep Nosema infections low is to make sure your bees are as healthy as possible and receive a robust, nutritious diet, which means supplementing during periods of dearth. Maintain young queens too. Equipment decontamination is possible if a colony becomes severely infected. The pests of honeybees can be broken down into two major groups: those that parasitize the individual bees and those that are pests of the hive itself. Varroa Destructor is a parasitic mite and the most damaging pests to European honeybees worldwide. In addition to transmitting viruses, it feeds on the fat body of the bees, which weakens their immunity and makes them susceptible to other environmental stressors. It is actually native to Asia, where its natural host is Apis cerana, or the Asian honeybee, which rarely experiences negative effects from the mite. While the mite itself is small as far as mites go, it is the largest parasite in the world when considered in relation to the size of its host. They are incredibly well-adapted bee parasites, with a flattened body to squeeze between the exoskeleton segments and hairy claws that allow them to grip the bee's hairs. Prior to 2007, Varroa was absent from Hawaii. It was introduced to Oahu in 2007 and then the Big Island in 2008. State laws that restrict the movement of bees and equipment between islands is responsible for restricting Varroa to these 2 islands only for the time being. The mites move between bees within colonies when the bees pass by each other, and move to other colonies during robbing or drifting. This is why it is so important to monitor for and control mites in your colonies. It isn't just about taking care of your bees, but being a good steward for your neighbor's bees too. To reproduce, the female mite leaves her adult host and enters a brood cell before the bees seal it. While they may enter worker or drone cells, they are more attracted to drone cells. The female lays her eggs on the developing honeybee pupa, which hatch and continue feeding on the pupa. They leave the cell when the adult bee emerges and move to infect other developing brood. On average, a female can produce 1 offspring per worker bee and 2 per drone, since they take longer to develop. When you consider that honeybees can rear brood year-round in Hawaii, this means that Varroa populations can increase 800-fold in a single year. Have I mentioned yet that it is important to monitor for mites? You can do this using a sugar or alcohol shake method, though the alcohol shake is much more accurate. I know people may be worried about killing their bees, but honestly, shaking them up in sugar for 30 seconds may not be good for their long-term health anyway. Take a moment to view the short video to see how the mite count is done.